Hey guys, it's Mrs. Miller. I'm here. We're going to work on absolute value equations today. Okay, so what is an absolute value? Well, an absolute value is a distance from zero. All right, for example, if I had the absolute value of -3, that would be 3 because the distance of -3, so here's 0, 1, 2, 3. The distance of -3 from 0 is 3. Okay? In algebra, if I had the absolute value of x equals 4, well, the distance of some value number, some number from 0 is 4. Well, there's two numbers. There could be -4 or +4. Okay, so x equals -4 or x equals +4. All right? So, here are some steps for solving absolute value equations. First, isolate the absolute value bars. Okay? Treat them like a castle. Okay? You have to bring down, first you have to get the armies away from the walls of the castle in order to bring down the walls. So, the first step is to isolate the absolute value bars. Second step, separate the absolute value equation into two cases. Case 1, when the interior is negative and when the interior is positive. Okay? And then solve for the unknown in both cases. So here, excuse me. All right, so apparently, 1 second, guys. Apparently the mailman's here, so if you hear barking, ignore that. Okay, so absolute value of x is 4. So that means if x is positive, then my answer would be 4. Or the negative value of x, which is the interior, equals 4. So x equals -4. Okay, so we have case 1. When the inside is positive, then the absolute value is itself. Or case 2, where there's the x is negative, so I have to multiply it by negative, and that would give me 4. So x equals -4. Okay? So here we go. First, I have to isolate the absolute value bars. So I have to divide both sides by 3. So the absolute value of x plus 7 equals 8. So this tells me two things. That if the inside is positive, let's assume the inside is positive. Okay, then the absolute value means, okay, well, since it's positive, x plus 7 has to equal 8. But what about, and then that means subtract 7 from both sides, so x equals 1. But what about if x plus 7 is negative? Well, if that's true, then I would have to multiply x plus 7 by a -1 to give me a positive 8. So now I can either distribute or I'm going to divide both sides by negative. And it's actually easier for me to divide both sides by negative. So I have x plus 7 equals -8. So subtract 7 from both sides. X equals -15. All right, so I have two answers. I have x equals 1 and x equals -15. All right, here we go again. Why don't you pause the video and try to solve it? All right, so if we're going to subtract 4, we had to get the absolute value bars by themselves. So absolute value of x plus 3 equals 0. Well, let's pretend that x plus 3 is positive. So x plus 3 equals 0. Well, that means x equals -3. Great. Well, what about if x plus 3 is negative? Well, I have to multiply it by a negative, equals 0. Well, that means, well, if I divide both sides by a negative, I have x plus 3 equals 0. Well, that's the same thing. X equals -3. So there's only one solution. if I get an absolute value equals 0, I only get one solution. Okay, previously, if I had an absolute value equals a positive number, I had two solutions. One more. Now, let's try another one. Well, the absolute value bars are not by themselves, so I'm going to subtract 8 from both sides. So I get -3 equals the absolute value of x plus 2. Well, this is telling me the distance from 0 of x plus 2 equals a negative number. Well, that doesn't make any sense because distance can't be negative. So this is no solution. Okay, so you can't have the absolute value of a negative number. All right, moving on. Chapter 5. Chapter 5 was when we graphed lines. This was an extension about absolute value functions. All right, an absolute value function is a function whose equation contains an absolute value expression. Okay, basically we've got f of x equals the absolute value of x minus 2, and then, 3 in front, maybe plus 1, that kind of thing. So in general, it looks like this. F of x equals a times x minus b plus c. Okay, this is general. That's generally what it looks like. All right? So an easy way to graph absolute value functions is to make a table. We've done that before. What's the absolute value of -2? Well, that's positive 2. What's the absolute value of -1? Well, that's positive 1. Well, the absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So that's a 0. So if I were to graph this, -2, 2 is here. -1, 1 is here. 0, 0, 1, 1, 2, 2. And the trend continues. So it would keep going out like this. Okay? This is the most basic absolute value function. It's called the parent function of the absolute value set of functions. Okay? So we've got f of x equals the absolute value of x is the parent function. Okay? When we graphed lines, we talked about parent functions for lines. Well, the parent function for the absolute value is this. Okay, notice that it has a lowest point here. Okay, this lowest point, let me get a different color. This lowest point is called a vertex. Okay, so that's the vertex. All right, it has an axis of symmetry because it's symmetrical across the y-axis for this one. And it goes right straight through the vertex. Okay. Let's talk about what each transformation does of f of x equals a absolute value x minus b plus c. Well, if a is positive, okay, the function opens up. So here I've graphed the parent function. The blue line is going to be the parent function. So here we have this absolute value of x. All right, 0, 0, 1, 1, 2, 2, 0. Let's see, we've got -1, 1, -2, 2, -3, 3. That's the absolute value of x. Well, if I multiply every vertical value by a negative number, okay, if a is negative, the function opens down. So here, if I look at my points, I would have 1, and now I'm multiplying. See, the absolute value, this is f of x equals negative absolute value of x. So that means take the absolute value and multiply it by negative, which means take the function and multiply it by a negative. So the absolute value of 1 is 1, multiply that by a negative is -1. So it goes down, it flips. Okay. If the equation looks like the absolute value of x minus some number, then the graph moves right that number of units. Okay, so here, I know it looks like minus a number, so you'd expect it to go back that way, or to the left. Instead, if you subtract a number, it moves to the right. Okay, so x minus 2 is actually going to be shifted right 2 units. If the equation looks like x plus a number, then the graph moves left 2 units. Okay, so x plus 2, absolute value, is moved left 2 units. All right. All right, well, if the c, or the a function, the a also, you can also treat a like a slope. Okay, so if a equals 3, then the rise is 3 and the run is 1. So instead of doing up 1 over 1, it's going to be up 3 over 1 in both directions. Okay, so you might have like a negative in one direction and positive in the other direction. All right. If I had 1/2, then it would be up 1 over 2. All right, when I graph it. If the equation looks like some absolute value plus a number on the outside, then that's a vertical shift. Okay, so this is vertical. Oops. All right, this is my vertical stretch. Okay. So if the equation looks like f of x equals absolute value of x minus a number, it goes down. If it's plus a number, it goes up. All right, vertical shift. Back here, if I have a change inside, that's a horizontal shift. Okay, and if it's positive or negative, then this is a flip. All right, vertically. All right, so let's see what we have here. Well, if you can tell what's different from the absolute f of x equals the absolute value of x, what's different? Well, I've got this x minus 5 business. Well, that means it's going 5 to the right. Okay, so it's a horizontal shift of 5. The plus 2 means that it's going to go up 2 units, so it's a vertical shift, vertical shift of 2. So instead of plotting 1, 1, I'm going to go up 2 and over 5. 1, 2, 3, 4, 5. So I'm going to plot that point right here. From there, I'm going to go ahead and do my over 1, up 1, over 1, up 1, and then over 2, up 2. And remember, I have a slope of 1, so it looks like this. Okay, I can graph it. Ta-da! So there we go. Okay, here's another one. Well, this one has a vertical stretch. Okay, and then it has a flip. All right, so my original one looks like this. It's got 1, 1. Okay. Oops. All right. It looks like this. Ooh, that is really bad. All right. Okay, those should be going through this point, this point, this point, this point, this point. All right. Okay. Let's attempt. All right, so that's my parent function. So what this graph is going to do is it's going to take all of the vertical values and stretch them. So instead of having a slope of 1, I'm going to have a slope of 2, okay? And then I'm going to flip it. So I'm going to just multiply everything by 2 first so you can see the vertical stretch. Okay, so here's 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So there's my vertical stretch. Okay, so before I flipped it, this is what it looks like. Okay. Now I'm going to have to flip it. So instead of being 1, 2, it's now 1, negative 2. Where's the red marker? I'm sorry, guys. I can't find the red marker. There we go. Instead of being negative 1, positive 2, it's negative 1, negative 2. And it still is at 0, 0. And then I can continue my slope there, my trend line here. All right, and then I can graph it. So which one's my function? This one is. All I really need is that one, so I can erase everything else. You can leave your parent function. Just tell me that this is f of x. Okay? All right, here's the last one. This one has a vertical stretch, or a vertical, stretch of factor of 1/2. Okay? And a vertical shift of down 1. Okay, so instead of starting here, I'm going to start down 1. And instead of going up 1 over 1, I'm going to go up 1 over 2 because it's got a slope of 1/2, if you want to call it that. Okay. There we go. Ta-da! And there we go. All right. First, go to edmodo.com and turn in your absolute value equations assignment and turn it in. In the response, list 3 things you learned, a good question, and bring to class a filled out notes for absolute value equations, your completed warm-up, completed cool-down, and your calculator. Well, bring your calculator. All right, see you guys in class. Bye.